Hi folks, we're going to take a look at the first example at the end of the investigation. So here we want to sketch this function, which if we look, we see is just a transformation of the function y equals absolute value of x. Okay, so we take a look and we realize that this is that a value. So if we think of our general transformation a f b times x minus h plus k, we realize that the a value, the vertical stretch, is 2. We see that the b value, well, there's no coefficient for the x, so the b value is just equal to 1, so no effect there. Our h is 2, and our k is 3. Okay, so let's go ahead. Now, the way in which, one way in which to do this is to take some special points on the parent function. So if you think of y equals absolute value of x, well, you definitely want to take 0, 0. Okay, and it would be good to have one point on either side here. So what I'm going to do is I'm going to take x value of 1, which gives me a y value. Absolute value 1 is just 1, so I'm going to take 1, 1. And then my third point, which I'm going to use, is on the other side, so I get that v shape, is I'm going to take negative 1, and the absolute value of negative 1, well, is still 1. Okay, so these are the 3 points that I'm going to use. Okay, so now it's all about knowing what these numbers here, 2, 2, and 3, do to the points. Okay, now one thing to keep in mind is that I've got some that multiply and some that add and subtract. And of course, we have to go in order. We have to go in order of operations, which is multiplications before additions and subtractions. Okay, so let's see what happens here. Let's start with the x values. Okay, so let's recall that our horizontal transformations are always the opposite of what we see in the input here of x minus 2. So we know that what we're doing is we're adding 2 to each of the x values. Okay, always the opposite of what you see. So 0 plus 2 is 2. Here we've got 1 plus 2 is 3. Negative 1, oops, sorry about that. Negative 1 plus 2 is just 1. Okay, so now let's see what's happening to the y values. Well, the y values, we see there's two things that's going on. We have this multiplication by 2, and then we've got the addition of 3. So let's do that here. So what's 2 times 0 plus 3? And then here we have 2 times 1 plus 3. And then here we've got 2 times, again, y equals 1 plus 3. And so now we can find our final points. Okay, so what do we have? We've got 2, 3. Here we've got 3, and 2 plus 3 is 5. Okay, and then here we have 1, and again 2 plus 3 is 5. And now what we have is we have 3 points on the transformed function. And so now what we can do, and I have my graph's a little small here, but so I'll use a different graph. Okay, so here I know I need to go up to a y value of 5. Okay, and I see that my x values are all positive, so I'm going to put my y-axis a little to the left, and I'll put my x-axis a little further down. Okay, so x and y, and I'll go up by 1 on each axis. Okay, since my numbers are fairly small. And so what I could do is I could plot the original function, okay, which is my absolute value function, and now I can plot the transformed function. Okay, and let's plot our points. So 0, 0 became the point 2, 3. Okay, 1, 1 became the point 1, 2, 3, and this is 1, 2, 3, 4, 5. Okay, and then here the point negative 1, 1 became the point 1, 5. And so now here we can draw our graph, and there's our final function. And it makes sense because it's been vertically stretched, okay, so kind of like pulled up, okay, so that's why it's thinner, and it's been moved along 2 units to the right and 3 units up as we see here. Okay, that's it for this one.